Hello once again, class. I'm glad y'all could join me today. Welcome to another edition of Mock Lecture here. And you'll notice right off the bat there's a major difference. Instead of using the liquid white that we normally have, I went ahead and today I'm using a black gesso liquid clear sort of mixture. But we're going to go ahead and get right into it. I'm going to have them run all the tools you need down at the bottom of the screen here so that you can do some math along with us today. Now you'll notice that it says today what we're talking about is solving multi-step linear equations. We've already done one-step linear equations. For example, 3x is equal to 7. All you need to do is divide both sides by 3, and then you're off to the races. But what if there was more than one operation affecting x? Like, for example, maybe it's 3x plus 2 is equal to 7, instead of just 3x is equal to 7. How are we going to tackle this? What you're going to want to do is start undoing the things that are happening to x. You'll notice it's being multiplied by 3, and then 3x is being added with 2 on the expression on the left. So if we started to undo this stuff that's happening, we're eventually going to get x by itself, which is really the goal of solving equations in the first place. Now, there's one of two ways that I would start. I think it's very common for students to want to do something like this, right? Divide both sides by 3. Perfectly reasonable. You're undoing the multiplication of 3 here, right? By dividing both sides by 3. And whatever you do to one side, you got to do it to the other side. And this is fine. The equation's balanced. What you do have to keep in mind, though, when you do something like this, is that you're really dividing both 3x and the positive 2 on the expression on the left by 3, right? Both of those things are going to be divided by 3 because they're separated by addition and not by multiplication. So the correct way to do this would be to have 3x divided by 3, at which point, the 3's would cancel, and that's fine, plus 2/3 is equal to 7/3. Okay? Now, I think it's very easy for students to make this kind of mistake. X plus 2 is equal to 7/3, where they just kind of cancel the 3 that's in front of the x, the coefficient that's in front of x, and then kind of forget about the fact that 2 should also be divided by 3. All right? Now, in this class, making mistakes is not the worst thing, right? In fact, I think making mistakes helps build a better understanding of the things that you should do instead. So making mistakes is totally fine in this class, and especially in math, because you can always undo the mistake that you made and start over. In any case, if we divide by 3 correctly, we should have x plus 2/3 is equal to 7/3. We'll go ahead and subtract 2/3 from both sides here. And the nice thing is, the 7/3 that we're going to be subtracting 2/3 away from, they have the same denominator already. And when you're subtracting fractions that have the same denominator, you don't need to worry about doing anything with the denominator. You simply subtract straight across like this, and you get 7 minus 2, which is 5. So you're going to get 5/3 as your solution. Okay? Now that is certainly one way to go. I don't think it's the way that I would go personally. I think that I would subtract 2 first. I want to try to get the 3x by itself, right, to start with. That gives me 3x is equal to 7, at which point I would just divide both sides by 3. We don't have to worry about also dividing by a 2 by 3 at all, so that's fine. And then we just get x is equal to 5/3, and we're done. Okay, I think I've exhausted this joke, so I'm going to take a break, and I'll be right back. Okay, so for example number 2, let's say that you want to solve 2/5 x minus 4 is equal to 1. Okay, now oftentimes I think about there's like a step-by-step process that goes on in my head. Like, here's things I need to do in order to solve this thing. What's the first thing that I should look at doing? And for me, especially for a linear equation, right, because this is going to be different than something that's quadratic, something that's got a squared power in there somewhere, I'm going to isolate the thing that has an x in it, or the thing that has a variable. I'm using x as kind of a placeholder for any variable. Sometimes the variable's q or r or p or whatever, n. So, but I'm going to isolate the variable term, which means together with its coefficient. So first thing I'm going to do is actually add 4 to both sides to undo this, right? That goes away. Whatever you do to one side, as long as you do it to the other, you're fine. 1 plus 4 is 5. So I've got 2/5 x is equal to 5. Okay, my next step is going to be to undo this coefficient, and it's here that I want to make a clear distinction. 2/5 is technically two operations. I think it's very easy to think about. I mean, it's 0.4, right? 2/5 is 0.4 as a decimal. So you've got 0.4x is equal to 5. And if you want to think about it like that, honestly, you could just divide both sides by 0.4 and then you're kind of done. 5 times 0.4 is whatever it is. Probably another decimal. But there's kind of really two things going on when you have a compound fraction like this, right? A numerator that's and a denominator that's non-1. So neither of them are 1. First, there's a division of 5, right? So I'm going to actually undo the denominator by multiplying both sides by 5. And in doing so, right, the 5s are going to cancel, right? Because technically now what this coefficient is it's 2 times 5 over 5, or 10/5, right? If you want to think about it like that. The 5s cancel, and that's why 10 divided by 5 is just 2. So we have 2x is equal to 5 times 5 is 25, at which point I'll just divide both sides by 2, and the answer is 25 halves as an improper fraction, right? That's actually fine, right? I think if you want to think about it like that, that's totally fine. There's a quicker way to do it, and it's to just actually multiply by 5 halves, right? If you multiply a fraction by its reciprocal, right? And a reciprocal is like if you have a over b and you multiply by its reciprocal, which is b over a, that's 1. That's always going to be 1, right? The a's cancel, the b's cancel. You have ab over ab essentially, so that's just the number 1. So then you just get x is equal to, right? Because this just turns into 1, right? This is now just 1 here. I can even put it in there. 1 times x is equal to 5 times 5 halves. When you're multiplying a number with a fraction, the number is technically a numerator, right? It's 5 over 1 is the number 5. And when you're multiplying fractions, you just multiply straight across. So you've got 5 times 5 over 1 times 2, and that gives you 25 halves. Okay, so that's how I deal with fractions in that case. And then you're done, right? That's it for that problem. Now this one is a little bit more complicated in the sense that there's kind of a lot going on the left-hand side of the equation, on the left-hand expression. We can't start by just isolating the x term because there's more than one x term, right? There's an x on the right-hand side, there's an x on the left-hand side here, and also it's trapped inside of a parentheses. So if we want to solve this, we're going to have to start a little bit differently. So now my first step is going to actually be to simplify both expressions. Now the one on the right's simplified. X and 16 aren't like terms, so that we're done there. But there's definitely some work to do on the left-hand side. First, I would distribute the -3. Now, distribution, if you don't remember, happens when you have something multiplied by something that's like a sum or a difference inside of a parentheses. So I guess maybe I'll just do this with using a bunch of variables. But if you have some variable multiplied by the sum of two other variables inside of parentheses, you'd need to distribute, right? And what you'd get is AB plus AC. Now that's very different than having something like this. You do not need to distribute when everything is being multiplied. In fact, I would argue that the parentheses here is almost unneeded. You could just write this as ABC, A times B times C. But going back to the problem, when we distribute -3 to x, we get -3x. And then when you do -3 distributed to 2, you get -6. Okay? At this point, I'm going to combine some like terms. So we've got 10 and -6. Those are like terms on the left-hand side. So we get 4, because 10 minus 6 is 4. So we have 4 minus 3x is equal to x minus 16. Okay? And then now we're done with this first step. Right? We simplified both expressions. Next, we need to get all of the x terms on the same side of the equation and all of the not x terms on the other side. So I'm going to look at my equation, and anything that has an x in it, let's move it to the right-hand side. And anything that's got a not x in it, anything that doesn't have an x in it, let's move that to the left-hand side. Okay, so -3x, I'm going to move over to this way by adding 3x to both sides. Okay, and that gives us 4x, because 1x plus 3x is 4x's. And then I'm going to notice that -16 does not have an x in it, so I'm going to move that left. And to do that, we have to add 16 to both sides. So we get 20 is equal to 4x, at which point we can now undo the coefficient for x by dividing both sides by 4. So we get 5 is equal to x as our solution. You know what? If I was going to add a fourth step down here, like maybe there should be a fourth step, it should be check answer. Right? And the way to check your answer is to plug 5 back into these two x's and make sure that the left-hand side of the equation is in fact equal to the right-hand side of the equation. I don't think I'm going to do that in the video, but you probably should check just to make sure you're getting your solutions correct. All right, here's another one. Now this one, you might look at immediately and say, Mark, why? Why are you doing this to us? Right? Because there's fractions. And I know that fractions aren't the most popular thing amongst students. To be honest, sometimes I find fractions a little bit annoying to deal with. But remember that fractions are still numbers, right? And if you really wanted to, you could turn all of your fractions into some kind of a decimal, distribute your decimal through. But then you still got decimals and stuff in your equation, and that's maybe equally, if not more annoying, at least in my opinion. So the way to deal with this is to first realize that it's not a harder problem because there's fractions. It's just a longer problem. There's just an additional step that you have to take for solving something like this. And that first step is actually getting rid of the denominators. Okay? And to get rid of a denominator, all you need to do is multiply both sides of the equation by the denominator that you want to get rid of. In this particular case, we get really lucky because if you get rid of a denominator of 4 by multiplying both sides by 4, you're simultaneously getting rid of a denominator of 2 because 2 is a factor of 4. Right? So on the right-hand side, actually, the 2 from the 1/2, the denominator 2 will cancel with one of the factors for 4, and you're just going to be left with actually 2 times k minus 1. And we'll see that in just a second. The first thing I did, though, is I distributed the 4 on the left-hand side because there's a minus. And keep in mind that when we're multiplying this 4 to this piece, right, it's this whole piece that we're multiplying 4 by. So we don't have to multiply to every single piece. So I get 4 over 4 is equal to 3k plus 8. 4 times 5 is 20, so we're getting a minus 20 here. And then on the right-hand side, again, multiplying 4 by the multiplication out front, so we've got 4 halves. But 4 halves is just 2, and 4 fourths is just 1. Okay, and now there's no fractions. Now it's just like the last example that we were looking at. In fact, I don't even have to distribute, right, on this side, because 1 times anything is just, we don't need to put the thing there, right? 1 times anything is just the anything part. So there's nothing to distribute on the left-hand side. You do need to distribute on the right. But at this point, we're going to simplify each side of the equation. All right, so that means I got rid of the parentheses on this side, and I'll start looking to combine some like terms. And then on the right-hand side, we'll do that distribution. 8 minus 20 is negative 12, and then 2 times k minus 1, 2 times the quantity, k minus 1, is 2k minus 2 after doing that distribution. So you have 3k minus 12 is equal to 2k minus 2, and then we're in the zone where all we need to do is move all the k's to one side and all the not k's to the other side. So I did this. I moved the k's to the left-hand side of the equation and all the constants, the not k's, to the right-hand side, which means we had to subtract 2 and add 12. But whatever you do to one side, you got to do to the other. So the 12s cancel on the left. The 2k's cancel on the right. 3k minus 2k is in fact just 1k. And then negative 2 plus 12 is 10. So k is equal to 10. All right. Now, knowing what to multiply each side by when you have a fraction could be a little bit tricky. If you want to make it simple for yourself, you could just multiply by each denominator. So let's say you've got like an expression that has like a denominator of 2 for like an x plus 1, and then you're adding something else that's got a denominator of 3 for x minus 2, and then that's all equal to like 2 times 11x or something. You could multiply everything by 2 to get rid of this one, everything by 3 to get rid of this one, and then everything by 11 to get rid of this one, right? And by the way, we're not going to look at anything this complex, but I'm just saying you could make it that easy. You get numbers and coefficients that are pretty big that most likely are going to reduce later on, but that is something that you could do. So here's an example. Let's say we have 4/5 x plus 4 is equal to 1/6 times the quantity x minus 11. I'm going to just notice there's a 4 as a denominator. So I'm going to multiply both sides of this equation by 4 to get rid of it, right? That requires distribution on the left here. And I'm just going to multiply the 4 with the 1/6 since this is multiplication. No distribution needs to happen since this is a quantity. You know, we will probably have to distribute later. Whatever this reduces to, that'll have to distribute in there. But not right now. We don't have to worry about that. So we get 5x plus 16 on the left-hand side, right? Because you're going to get 4 times this 5. The 4 all divided by 4, so the 4's cancel, and you're just left with the 5. And then 4 times 4 is 16. Here I just put 4 over 6, right? Which technically reduces, but I decided not to reduce it because now I'm going to notice there's a 6, right, in the equation. In the denominator, I should say. So now I'm going to multiply both sides by 6. Keep in mind that you do have to distribute on the left. So we get 30x plus 96 is equal to, now here when you multiply 6 with this 4/6, the 6th cancels, right? So you just get 4 times x minus 11. And now there's no fractions. So I'm actually not going to finish this because at this point you would just solve this like we had been the last couple examples. So that is certainly one way to do it. Now, I think what I would do, right, let's just go back to the beginning here. We've got 5/4 x plus 4 is equal to 1/6 times the quantity x minus 11. I'm going to look for the least common denominator between 4 and 6, right? It's effectively the least common multiple, right? So I just started listing multiples of 4. So 4, 8, 12, 16, 20, 24, so on and so forth. And then I tried to pair that with some multiple of 6, and it happened almost right away, right? Multiples of 6 are 6 and then 12. Now what that tells me is if I multiply everything by 12, then I'll get rid of both 4 and 6 as denominators at the same time, right? And I'll show you how that works. If you multiply both sides by 12, on the left-hand side, factors of 12 include 4 and 3. So the 4's cancel. And so you're just going to be left with 3 times 5 as the coefficient for x, which gives you 15x. And then I distributed the 12 to the 4 as well to get 48. And then on the right-hand side, 12 times 1 over 6, you could probably just see that reduces to 2, but I broke it up, right? 12 has factors 6 and 2, so the 6's cancel, and you're just left with 2 there, and then that's multiplied by x minus 11, and again, we get to a point where we have no fractions. Now, you might be looking at these and saying, well, hold on, Mark, those are different equations. Not really. If you divide this whole thing by 2, right, then you get 15x plus, excuse my handwriting, 48 is equal to 2 times x minus 11. So they're the same. One of them was just unreduced because I decided not to reduce that to 2/3 for some reason. I actually don't really know why I didn't do that, but that's okay. If you want to solve this one, go ahead. You should end up with negative 70/13, which isn't the most attractive answer ever, but there you go. All right, so I think we are going to call it here. I think that's enough. This video is long enough. If you guys have any questions, please leave a comment down below or send me an email. Thanks a ton for watching, and I'll see you in the next one. And from all of us here at Mock Lecture Corporation, I want to say thanks for watching, and God bless, my friend.